Hey guys and gals, it's Mr. Veith. Hey, we are working on adding and subtracting fractions with unlike denominators. That's where our skill is going to be. The biggest thing to know is it's definitely not that hard. We have to do a process, but in doing that process, we need to make sure we understand why we're doing it and why we can't just add the fractions straight across. So the more you understand about why you can or cannot do something, the easier it's going to be when I start teaching you other types of things to do. For instance, when I start teaching you how to multiply fractions, that concept's different than adding fractions. Okay, and if you don't want to get that mixed up, understanding why we can or can't do something will better help us to not make silly mistakes down the road. Okay, so we'll talk about it. We've talked about it in class. So hopefully it's helping us out a little bit. Okay, so here we go. Adding and subtracting unlike denominators. Okay, so real quick, if I go to add here, and I'll just start something as simple and easy as basic as one of the easiest adding and subtracting fractions we can have. 1/2 plus 1/3. So we've talked about why can't we add these two fractions? We can't add these fractions because one, our denominator is not the same. Remember, a denominator tells us what our pieces look like or what makes up our whole. So I cannot just add 1/2 plus 1/3 because they don't look the same. In order to add fractions, you have to have fractions that are equivalent. They have to have the same amount of pieces cut. The pieces have to look the same. In order to get these pieces to look the same, we're going to have to come up with some equivalent fractions. Okay, fractions that are the same value but different cuts. We got to make new fractions that we're able to add together, but the pieces need to be the same. In order to do that, we're going to have to change our denominators. So down here, we're going to write the number 2 and the number 3. Okay, we have to get these denominators to change. And we're going to do that by something called LCM, least common multiple. And what we're going to do is we're going to list the multiples of 2 and 3. And whatever they have in common, the least means first, the smallest number they have in common. So when I start to list these multiples, the first thing they have in common, that's the number I want to pick. Common just means that something they share, that they both have. Okay? And then multiple is when we count by that number. So smallest number they share when we count by the number. So how we're going to do this is I'm just going to count by 2s. And I'm going to do the first 5. I always recommend doing the first 5. Okay? So here we go. 2, 4, 6, 8, 10. So we did the first 5. Now we're going to do the 3s. And wherever we hear a common multiple, so if I say one of these up here, I get to stop. If I don't say one, then I just got to keep going, and we'll list 5 more until we find a common multiple. So let's go ahead and go, but let's be mindful each time. 3, 6. Oh, beep, 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 beep. So our flashers go off because 6 is a common multiple. So look, they both share the number 6. So guess what that is? That is now going to be our new denominator. So I'm going to come up here and notice I have my big, huge equal sign right there because I'm making an equivalent problem. This is the old problem. This is the new problem. Okay. And now the new problem, since figuring out what they have in common, now the new problem tells me I have common denominators of 6. So notice how I start out. I put what I know. I know the denominators are 6. That's what I just figured out. I know I have a plus sign because I'm adding. Well, now I got to figure out what are my new numerators. And notice I said new numerators. I can't just bring these two guys over because if I change the way my pieces look, that means I'm going to get more pieces. Notice I had 2 pieces, now I have 6. It was cut into 3 pieces, now it's cut into 6. So my pieces got smaller, therefore I'll get more pieces because they're smaller. So what we do is we take this number, and the first fraction on the left-hand side is the first fraction on the right-hand side of the equal sign. So this guy and this guy are equivalent. So that's why we're going to draw an arrow, and we're going to say, how did I go from 2 to 6? And you're going to say times 3. Okay, so you know You tripled the cuts to get to 6. That's what we did. We took 2 times 3 and we got 6. That's how we got a denominator of 6. But then we got to follow our golden rule. Whatever you do to the bottom, you must do to the top. And that's what makes it equivalent. Whatever you do to the bottom, you do it to the top, and that leaves the value the same amount. If you did not do the same things, or we just put the 1 over here, you're no longer equivalent. You're smaller. So if I'm going to triple the pieces, I'm going to triple the cuts and make my cuts smaller. I'm also tripling the amount of pieces I get. So I'm going to take this number over here, and I'm going to make this a 3. From this side, I'm going to go from 3 to 6. And I got to ask myself, well, how did this second fraction become this second fraction? And I got to look at it and say to myself, okay, well, how did I go from 3 to 6? And you would say you times by 2. So at this time, you doubled the cuts. Okay, and again, you got to keep with your equivalent fraction rule. Whatever you do to the bottom, you must do to the top. So I'm going to come over here, and I'm going to multiply by 2 here because I did the same thing down to my denominator. So I'm going to just draw my arrow here, showing you the new number goes here, and that's a 2. Now I have common denominators, so my pieces look the same. I have 3/6 of a pizza. I have 2/6 of a pizza, so I can just add these straight up. Now, when I add, I'm only going to add the numerators. The reason for that is because remember what we talked about. This is why we hit fraction concepts so hard the first week and a half. The denominator tells you what your pieces look like. His job is to say what makes up your whole. So you don't add these pieces up. His job is just to say, hey, your pieces look like sixths. A sixth is what makes up a whole pizza. Okay. The numerator represents what you have. This guy represents you have 3 1/6 pieces. You have 2 1/6 pieces. So altogether you have 5 1/6 pieces, or we just say 5/6. So that's why we add the numerator, because that represents what we have. We don't add denominators because that tells us what our pieces look like, or how many pieces make up our whole. Okay. So when you go to do this, you get them to be the same. You need denominators to be the same because the pieces have to look the same to add them. But once they do that, you don't keep adding the denominator. Okay, let's try a different one. Okay, let's go a little bit bigger. Let's go 3/4. Let's go minus this time 2/3. Okay, so right away you should say to yourself, these aren't the same. The pieces don't look the same. I need those pieces to look the same. What do? We have to come up here and use the least common multiple, which means I'm going to list the multiples. And when I list, I'm going to write the first fraction, the first denominator first, the second denominator second. Do not mix those up, okay? Because that will mix up your new fractions, and you'll have it. It won't end up being equivalent. Now, my rule of thumb is I always do the smaller multiple first. I feel like it saves me a little bit of work, so I'm going to try it. So even though I have the 4 first, I'm just going to list the 3. If you don't do that, that's fine. So 3, 6, 9, 12, 15. And I'm just going to list the first 5. Then I'm going to list the 4 facts, and I'll stop if I hear something common. So 4, 8, 12. Oh, beep, 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 beep. There it is. See, this is why Mr. B told you how important it is to know your facts. These are easy numbers right now, but just wait till they get to be pretty long. Well, now we know they have a 12 in common, so now we know that's our new denominator. So I'm going to come over here. There's my equal sign. So I'm going to set up the new problem, the new equivalent problem. I know denominators are 12. I also know there's a minus sign. So I'm going to get everything set up right now. Okay. The only thing I need are my new numerators. But if I change the denominator, I also have to change the numerator. So again, I'm going to draw my arrow to show you that this first denominator is the first denominator here. And you got to ask yourself, how'd you go from 4 to 12? And you multiply by 3. Whatever you do to the bottom, you must do to the top to keep it equivalent. 3 times 3 is 9. So now you have 9/12. Now I'm going to come over here and do, how many times can 3 go into 12? Or I'm sorry, how many times? 3 times what? Made 12. How did I make 12? You multiply by 4. You quadrupled the cuts. And the golden rule, whatever you do to the bottom, you must do to the top. So now you have 8. So now you can subtract. Keep in mind it's subtraction. So you can go 9 minus 8, and that's 1. And then what do your pieces look like? They look like twelfths. So my answer is 1/12. Okay, so it's a pretty easy concept to understand. If adding, you're going to get bigger, subtracting, you're going to get smaller, but you need to make sure your pieces look the same. You cannot add pieces that don't look alike. If they don't look alike, it doesn't work. Okay, you're going to have wrong fractions. Okay, all right, let's try another one, and let me show you a little bit bigger one. What if we add 6 sevenths minus 4 ninths? So again, now we have to know our facts. And we're going to we know our denominators are not the same. We need our denominators to be the same. So right below it, I'm going to write 7 and 9. And I'm going to start listing multiples of my denominators to figure out what I could do. So I'm going to start with 7. 7, 14, 21, 28, 35. Now I'm going to start with 9. 9, 18, 27, 36, 45. So nothing in common yet. So what do I do now? I got to go back up to my 7s and do 7 more, or do the next 5. So 7 times 6 is 42, 49, 56, 63, 70. So now I'm going to do 9 facts to try to see what I have. 54, 63. Oh, beep, 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 beep. There it is. So had to do a lot more facts that time. Okay. So we're going to come over here, do 63 minus 63. So now I have new denominators. Now I need new numerators. I'm going to draw my arrows to show you I went from 7 times 9 to get 63. Whatever you do to the bottom, you must do to the top. Knowing my facts, I know it's 54. 9 times 7 gives me 63. Whatever you do to the bottom, must do to the top, and that's 28. Now, I can't subtract that in my head, so I'm going to come over here and actually just subtract so I don't make silly mistakes. And it looks like I have 26 when I subtract. So 26 over 63 is going to be my answer. So again, you're going to have to show a decent amount of work. It's not hard to understand, but you want to make sure that you're fully grasping why we're changing the denominators. When you add pieces, you're adding alike pieces together. Okay? Let's try another one. We'll do one more. 4 eighths plus 2 sixths. Now, if you see, what you've probably tended to notice is like, wait, Mr. Beef, if I just multiply the denominators, 2 times 3, I get 6. And then 4 times 3, and I get 12. It even works 7 times 9 to get 63. So can't I just multiply the two denominators to get a common denominator and skip all this work? Well, let me explain. No, you can't. Yes, you can, but no, you can't. And what I mean by that is, yes, you could multiply those two. Yes, you would get a common denominator. However, you don't always get the best one. And this is going to be proof positive. So if I was going to just multiply these two to find a common denominator, I could do that. But 8 times 6 is 48. So just kind of keep that in your head. And now let's do it the way I'm instructing you. So you need to do 8s and 6s. I'm going to do my 6 because it's smaller. 6, 12, 18, 24, and 30. And then when I come here, I'm going to do 8, 16, 24. Oh, beep, 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 beep. So notice, if I would have multiplied these two, I'd have went all the way to 48 when I could have used the better denominator of 24. And that's what we want to do, guys. We want to use the best denominator, not the easiest denominator. Okay, use the best one. So now I know my denominator is 24 because of my LCM work down here. I'm going to draw my arrow to say how many times did I go from 8 to 24? That's times 3. Whatever you do to the bottom, you do to the top. 4 times 3 is 12. So same fraction right there. These two are called, the ones you're drawing arrows to, are equivalent. Now you got to ask yourself, how did I go from 6 to 24? You times by 4. Whatever you do to the bottom, you've got to do to the top. And so 2 times 4 is 8. Okay. So when I come to add this, I'm going to go 12 plus 8. I can do that in my head, but I want to show you if you can't, what you would do. You would come do side work, and you'd have 20 24ths. Now, there is something called simplifying. I'm not going to actually force that upon you right now, but you could simplify, but that's for a later date. Okay, so hopefully this helps and makes sense to you. If you have any questions, obviously, please reach out. All right, thanks for watching.